In previous lectures, we've looked at some of the vernacular of programming in general. Things like what is a class, what is an object, what's an attribute, what's a method, and what's a variable. Those things are general to programming. In this lecture, we're going to see how they specifically apply to Android programming. And what we're really going to focus on is where people tend to make mistakes. So we're going to start with the example we worked on in our last video on methods and on-click. And why don't we start with a method? We know that this is a method here. And we know that a method has a signature, public void search clicked view v. Okay, so this is a method with a signature. People get confused between a method and a method call quite frequently. So let me describe what a method is. A method has a signature, as we know. It has an access modifier, return type, method name, and parameters. So what does that mean? Access modifier it tells us who can call the method. You see we have three methods here, and each of them, well, these two at least, have a modifier called public. That's the default for us at this point. That will work fine for us for this class. You can go ahead and assume that access modifier is going to be public. Now, the next thing is you see the return type, and the one above we have a Boolean, and the one below we have a void. Boolean means that when the method finishes executing, it should return either true or false. Void means it should return nothing at all. You notice that the Boolean has a return statement, the void has nothing at all. It does not have a return statement. A common mistake I see here, and by the way, when I talk about common mistakes, I'm thinking about when I've taught introductory programming before. I think about the things that frustrate people. Common mistake that I see here is when people have a return type and they fail to put the return statement in. So watch, if I comment out this return statement, and in Java we can comment with 2 slashes, that's the slash to the left of the shift key. You see that as soon as I comment out this return statement, look what happens up above. We get a red line, okay? And it says add return statement or change the return type to void. In this case, we're doing something called overwriting a method. And that's a fairly deep programming term. But let's just suffice it to say in this case, we do need to keep that return type as Boolean. So the correct fix for this is to add that return true, just as you see there. As soon as we do that, you'll notice that the Boolean, or that the method, the red underline, goes away. And then we're good. If you see a red underline, then that means there's a syntax error. A syntax error means there's an error in the grammar of your program. My advice to you is if you do see a red line, fix that immediately before doing anything else. Priority number 1 is to fix that red line. Fix it immediately before doing anything else. If you continue to work, you're just going to be making more work for yourself in the future. So it's best to address the red lines immediately. They're what we call syntax errors, errors in grammar. So public void, public Boolean. Remember, void means no return whatsoever. It means the method is going to do something. In this case, and allow me to control M so we can focus on this. In this case, what it's doing is this method is simply showing a pop-up. It's showing a pop-up that says that the search button was clicked. So there's nothing that the method actually needs to return. If we did add a return statement here, let's say that return true, watch. The return true is now going to redline because it says void methods cannot return a value. If you don't know what a void method is, that message makes no sense at all. But if you know what a void method is, which is what I'm telling you right now, then the method makes sense. A void method is a method which has void as a return type, which means nothing gets returned. If you try to return something, you can't. So what will give you a red line? The proper fix, remove that return statement, or if you actually want to return something, change the return value. Next, we have the name of the method. The name of the method has to be unique. In most cases, there are some cases where it can be the same as another method. That's called overwriting or overloading, but that's beyond the scope of this video. So the method name is something that we make up. Typically it will be camel case, which means the first word is entirely lowercase, and every word thereafter has an uppercase letter. A mistake I see a lot of times in introductory programming is someone puts a space between words. That definitely will not work. The method name cannot have a space. It also cannot have special characters like star in it. It can't begin with a 1 or a number. It can't begin with a number, but you can put a number in the middle of it if you wish. As long as the first character is not a number, that's fine. So those are some syntax issues that I see with methods. Now, one thing that's just kind of an lack of clarity, it's not truly an issue, but a lack of clarity, is if you give a method a silly name. Like if we call this test or temp, and then maybe we had another one we called temp1. That's not very descriptive. Method name is something that you get to choose, but choose wisely. Choose a method name that describes what the method is doing. Okay, choose a method name that describes what the method is doing, because the more descriptive your method names and your variable names are, the less comments you need in your program. Next, we have a parameter list. This is information that is passed into the method. Information passed into the method. Okay? So, for instance, let's make a brand new method. In this method, we're going to say public int sum. Okay, operand 1. I'm sorry, public void sum int operand 1 int operand 2. So what that means is we're going to add two numbers together. And this is naturally kind of a silly example that's meant to demonstrate a point. So we're saying this is a public method, which means anyone can call it. Again, in this class, let's assume all methods are public. In more advanced classes, we can learn that methods can be private, protected, or something called package protected or friendly. For our case, we'll just assume public for now. Now we're returning an int. And why are we returning an int? Because we're summing two numbers together. And the two numbers we're summing are the first operand and the second operand. Now notice that as soon as I type this method name, I get a red line. And remember the golden rule of red lines. If you get a red line, the best thing to do is to immediately fix it. And what's interesting here is it says this method must return a result of type int. Well, that's kind of funny because we've given it a return type. We simply haven't put the return line in there yet. So this is a case where we actually need to do something else. We need to take one more step to resolve that red line. Now, luckily, there's a quick fix for it, and one is just add a new return statement. Let's go ahead and let Eclipse do some work for us. I'll click on that, and it's just going to return a number. Okay, so we'll change this around a little bit. Right now, it's just returning whatever the second operand is, but we'll fix that. We just want to take care of the red line because that's priority number 1. Okay. Now, what we can do is we can add operand 1 and operand 2 together. We simply use the plus. Okay, we simply use the plus. Now, if we have a statement in Java, we'll terminate it with a semicolon. Until that point, we'll get a red line. Now, what we're doing here is we're doing some type of operation. And what we probably want to do is we want to store that into a variable. Okay, we want to store that into a variable. A variable is a named place in the computer's memory, typically in its temporary memory or in its RAM. When we create a variable, we know we have to give it a name, which is unique, and we have to give it a type or data type. What are the data types? If you go to my UC homepage, which is ucjava.com, we can scroll down and click on 32IT205 Computer Programming 1. One of the things you'll see here are some slides that discuss what data types are. If you saw the optional video that discusses Brandon's binary calculator, one of the things I talked about is how computers represent memory, and they represent memory with zeros and ones. We can convert those zeros and ones to a 10-based number system, or a decimal number system. And from that, we can convert zeros and ones to numbers that you and I know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can either use those numbers as numbers, or we can map them to something else. Or we can combine them even further and put several of these variables together and have something that is more complex. So if we're using a variable as a fairly close relation to its zeros and ones, in other words, if we're using just a raw number, then that's typically what we would call a primitive. If we're combining variables together, then we would call that a class. Let's look at the variable types that we have. Okay, we know first that a variable has to have a name, which is unique, and a type. A name and a type. Those are the two things we require with a variable, a name and a type. Okay, so let's look at some of the common types. I'm going to Data Types Intro, and again, this is from my Computer Programming 1 course, 205. Data Types Intro, and then I'm going to choose Data Types. Actually, that one doesn't have much information. Let's go to whole numbers. These are the data types that represent a whole number. By a whole number, I mean a number that does not have a decimal point. A number that doesn't have a decimal point. And we have 4 different options here. The data type called int is the most popular at 4 bytes. The data type called short is about half the size of an int. Data type called long is twice as large, and a data type called byte is exactly 1 byte. What's interesting here is that you see that a byte can hold data in a range from -128 to positive 127. If we double that space and use a short, the capacity of number we can store is much larger. It's -32768 to 32767. Now, why the difference? Because those zeros and ones are actually powers of 2. So if we double the amount of storage we give to a variable, we can hold a much bigger number, and literally an exponentially bigger number. An int is the most common because most of the numbers that we have are minus 2.1 billion to plus 2.1 billion, somewhere in that range. And then a long is a much, much larger number. Now there's an interesting story about the short data type, and the lesson here is choose your data type wisely. In Christmas of 2003, it was either 2003 or 2004, my wife and I were planning a trip to Las Vegas from the Cincinnati area, and at the time, Comair was an air carrier, which has since been folded into Delta's other regional airlines, but it was a regional carrier based out of CVG, based out of Cincinnati, with a hub in CVG, and I can tell you I very much miss those days, having a lot of direct flights on Comair. But nonetheless, on that, Cincinnati had a historically bad snowstorm up to that Christmas. It snowed nonstop for 3 days, a total of about 24 inches of snow plus ice, which is far, far more than Cincinnati had ever seen in a long time. As a result, a lot of flights out of CVG Airport were delayed or canceled. But to make things worse, Comair's rescheduling system actually failed. What happened, and I have pulled up an archive story, I tried to find one from the Inquirer itself, but what happened is because they had to cancel so many flights, their scheduling system was overwhelmed and crashed. And their scheduling system could no longer handle any more aircraft reschedules or flight crew reschedules. What happened, I remember reading this in the Inquirer, and again, it was a day I was expecting to fly. Luckily, I was not on a Comair flight, and my flight was safe, but what happened is I read in the Cincinnati Inquirer that Comair's rescheduling system could only hold a maximum of 32,767 reschedules. As soon as they got to reschedule 32,768, basically what happens then is the odometer flips over and you get a very large negative number instead of the positive number you were thinking of. And as a result, they couldn't reschedule anything and they completely canceled flights for 3 days, which was naturally very expensive. Now, being based in Cincinnati, I told this story several times, and it wasn't long before I had a ComAir employee in class who told me that what it was is they knew they had to replace the system. They had several things that delayed that replacement. There was a strike in 2001 that put them behind. There was 9/11, which cost the airline industry quite a bit. There were several things that ended up delaying the software upgrade, and they were within only months of actually replacing it when this disaster happened. So, lesson learned: pick that number wisely. Think of a reasonable number. Similarly, when I worked in banking, one of the things that I did was loan finance for car inventory, for dealer inventory. Not for when you buy a car, but for the inventory that sits on a dealer's lot. And the program that I wrote would send money, would basically allow a dealer to finance cars on their inventory. And what would happen then is the bank would make a loan and put that loan money into their checking account. Similarly, they could pay off that loan as they sold these cars, and then the money would go the other way. So every night, this program processed about $11 million. And one time, it failed. And I went to see, well, what happened is it puts together a checksum where it wants to make sure the file is valid. So it adds up all of the routing and transit numbers. Those are the numbers on the left side of your check when you have to enter a direct debit or something like that. And I used an int to hold all of these routing and transit numbers. Now, routing and transit numbers are usually 9 characters. So you see a routing and transit number is basically like 100 million, basically, is what it is. That's, if you were to read it as a number, that's what it would be. It didn't take too long before adding up these routing and transit numbers, they flipped over 2.1 billion. And when that happened, the checksum no longer worked. The file went to the Federal Reserve. Federal Reserve rejected it. And as a result, there was $11 million that was supposed to change hands overnight that did not change hands. And so the next day was a very busy day for me. Needless to say, I had to go back into the office around midnight. I saw immediately what the problem was, fixed it, but unfortunately by then it was too late to run it. So we had to do a lot of manual work the next day and basically wire money to get it into the accounts. And then when the file actually ran the next night, we had to do wires again to take the money back out. So it was a lot of work. So choose wisely. Now, what's interesting here is that memory is really not as expensive as it used to be. So we don't have to nitpick as much as we normally would on the size of memory. But that's on a PC or a laptop. Now we're back into the case of a mobile phone where memory is a bit more precious. So we want to think very carefully about the memory that we're using. On the Plant Places mobile search by color, it has to process a lot of numbers and it has to do it very quickly. So in that case, when I was doing the color indexing of an image, I did not use an int just because there were so many of them. If you take a 1 megapixel image, even there are quite a few. It's quite a humongous image, and to process that is going to, if to touch every single pixel, is going to take a lot of time. So in that case, I went for a more efficient data type, first byte, and then I eventually upped it to short. But it was just because I had to account for every pixel on the screen, and I had to remember the decision that I made was going to be multiplied by every pixel in that image. So we kind of are going back to where we used to be, where we do want to be very careful about memory, especially in a computation-intensive operation. Okay, so those are number variable types. We also have something called floating point. Floating point variable types can hold a decimal. Okay, float or double are two big options here. There's something a little bit tricky called floating point arithmetic. And what that means is, what is 1 divided by 3? Is it 0.33? Not really, that's 33 100ths. That's not the same as a third. Is it 0.333? Not really, that's 333 1,000ths. That's not the same as a third. So a computer has a finite limit of how many decimal positions it can hold. And if you have a repeating number, like 1/3, eventually you run out of room, and you have to go with something close. That's simplifying things a little bit, but that's something called floating point arithmetic. So you have to be careful with that, especially when you're dealing with a data type that uses the very distant decimal points, like GPS, latitude and longitude. Many times the 5th or 6th decimal point is very important, and floating point arithmetic can make that number different from reality, so we have to be careful. In general, if you want to hold a decimal, I would recommend using a double. If you need absolute precision, there's something else called big decimal. That is opposed to a double. Big decimal will actually remember operations that have happened to a number, and it can replay them. So it remembers 1/3 not as 0.33333. It remembers it literally as 1 divided by 3. So for our purposes, though, double will be fine. There are just a couple more. We have character and Boolean. Character, basically we take those zeros and ones, map them to a number, and then that number we map to a letter. In the old days, we kind of had a snooty look and feel of this, and we said that, well, you know what, English is the only language that matters. Let's just map them to A through Z uppercase, A through Z lowercase, and a few special characters. In the 70s and the 80s, that might have worked, but it won't work now. Think very seriously who your audience is. For instance, today I looked, we had a pretty good ad revenue day for Plant Places Mobile. 2/3 of that revenue came from France. So think very seriously about where your audience might be. And what we tend to use today is Unicode. Unicode is a different mapping mechanism that has more capacity for internationalized letters. The other data type we have is Boolean, which is a true or a false. Now, character data type can only hold one letter. What we can do is we can put those letters together and make a string out of them. And a string is text. A string is a collection of characters, essentially. A string is a class. It's a more complicated object. It's not a primitive type. It's a more complicated object. So, when you're writing your program, think about your data types that you're going to need when you declare a variable. So I will say int total. That's my variable I'm declaring. Okay, and I'll put a very clear mark here. Declare a variable. Okay. Now we're going to say add together two numbers and assign that to a variable. Okay, so we're adding together the two numbers. Now the trick is we need to take total and assign the sum of operand 1 plus operand 2 to this variable called total. And what we do here is something interesting. We use the equal operator, but equal doesn't mean equality in this case. Equals means take what's on the right, evaluate it, take the result of that, assign it to the variable on the left. Okay? Take what's on the right of the equal sign, evaluate it, and then assign the result of that to the variable on the left, which is total. Okay? Now we have our total. Now we finally can return the total. Okay? Return total. And there we go. And we'll save. Okay? So we're declaring a variable called total. We're summing two numbers together, assigning that sum to the variable named total, and then returning the value in the variable called total. Remember, when we declare a variable, we're reserving space in memory. So that's what's happening on the first line. We're reserving space in memory. Assignment means we're setting those zeros and ones. So we are adding together one number with a second number. Whatever the result of that is, are the zeros and ones that we're setting in this variable called total here. Okay, and then finally we return total. Okay, so let's call this method, and let's take the result, and we're going to put it in our toast. Okay, so what I need to do, there we go. What I need to do is I need to call this method. Call the method named sum. Okay, sum 1 comma 2. Okay, and terminate with a semicolon. Now, a few notes here. First of all, I have to make a difference between a method and a method call. Okay, make a very important difference between a method and a method call. This is a method. A method has a signature, it has an open curly and a closed curly, and that determines the boundary of the method. That says what the boundary of the method is. Now, this is a call to a method. Okay, so you see this is a method here called sum. This is a call to the method called sum. For instance, take my phone. My phone has a phone number beginning with 513, Cincinnati Exchange. Okay. Now, that phone number, ever since I got out of undergrad in 1997, I got my first mobile phone. That phone number uniquely identifies my phone. Okay? My phone has a phone number. Now, if you call me, you might go to your contacts. You might go to your directory, find my name, and press call. And associated with my name is my phone number. Okay? Your phone might have my phone number in its directory, but that doesn't mean that your phone is the same as my phone. You just have a way to call my phone. You have a way to reference my phone. So here we go. This is the phone named sum. This is a call to that phone named sum. Okay? This is the method. This is a call to a method. That gets confused a lot in introductory programming. I know a lot of people get confused with that. What is a method versus what is a method call? But just think of a phone analogy. This is the method named sum. This is calling the method named sum. Okay. Okay, so when we call the method named sum, we know it's going to return a value, and we want to do something with it. We want to store that value. So what we're going to do is we're going to say int value equals sum 1 comma 2. Remember what that means. The equal sign doesn't mean equality. It means evaluate what's on the right, put that value, whatever it is, in the variable on the left. Okay? Now, one very important thing, do you see that? Evaluate what's on the right, assign it to the variable that's on the left. If we're doing this by calling a method, this variable type has to be identical to the method's return type. A mistake I see a lot of times is people don't do that. Watch what happens when I change that to a string. We're going to get a red line. And what it's going to say is type mismatch, cannot convert from int to string. What that's saying is, the method I'm calling is returning an int. You're trying to store it in a variable of type string. Remember, the variable type tells us how to decipher the zeros and ones. Okay? If we're getting an int back from the method we're calling, we must save it into a variable of type int as well. Okay? And there we go. Now finally, we can change our pop-up. With the message, we can say the sum of 1 and 2 is, and then we can say plus value. Okay, this is what's called concatenation. We're taking a string, and on the end of that string, we are appending or concatenating an int variable. We're taking a string, and on the end of that string, we're concatenating an int variable. That int variable will be converted to a string and then appended to the end of this string here. Okay. So we've looked at declaring variables. Okay. And we've looked at methods, and I want to point out a few other common things that I see. First of all, this is what's called a local variable. A local variable is alive from the point at where it's declared until it goes out of scope. And the scope is defined as the open and closed curly that contains that variable. So in other words, this variable total is alive for this entire time. Could I take this toast here, instead of saying plus value, could I say plus total? I can't do that because you see this variable total, because it's only alive in this highlighted area, this highlighted area doesn't know who it is. Okay, so that's what we call variable out of scope. A local variable is a variable that's declared many times within a method, and it can only be used within that method. Again, a local variable is a variable declared within a method, and it can only be used within that method. That's something I see very frequently. Someone will declare a variable here in this method, try to use it here. That simply won't work. Let's change this back to value. Value is declared here. It can be used right here because a variable is alive from the point where it is declared until the closed curly of the block where it's declared. So the area I've highlighted in blue, this is all the area where you can use the variable named value. If I tried to put value down in the lower method, we'll find that it will redline because it doesn't know who value is, okay? Because value is out of scope. So be careful with that. A few other common things that I see. First of all, sometimes people will do things after the return statement. You can't do that. The return statement must be the last line of a method if there is a return statement in that method. So if I said system.out.println here, just put in a dummy line. If I put in any instruction after the return, it's going to redline and it will say unreachable code. That's because the return statement is the last thing that we'll see in a method. So unreachable code. That's a good quiz question suggestion. What happens if you put a statement after a return? You'll get unreachable code. Okay. Okay. Other things that I frequently see. Forgetting to terminate a line with a semicolon. That will give you a red line. The only trick is, that's pretty good. Syntax error, insert semicolon to terminate, to finish statements. Okay. Another common issue that I see, a method. Okay, a method will have its parameters in parentheses and then an open curly and a closed curly. Those must stay in balance. If you have an open curly, you must have a closed curly. Okay, if you have an open curly, you must have a closed curly. Okay, they must be paired up. What's nice in Eclipse is if you put your mouse cursor next to an open curly, it will take the corresponding closed curly and put it in a gray box. So you can count your brackets, make sure they match up. Let's say that you can't see the closed curly. What you can do in Eclipse is put your cursor next to the closed open curly, hold down Control Shift, and then touch the letter P. And what that will do is that will take you back and forth between the open and closed curly in a block. That's an easy way in a long class to navigate around the class. It's a nice one. Okay. What happens sometimes is people will accidentally delete a curly, and then you'll get a lot of red lines. And the red line doesn't necessarily say you're missing a curly. That's where it gets confusing. Okay, let's look at this red line. This one says syntax error, insert closed curly to complete method body. A lot of times what people will do, I'll say you're missing closed curlies. What they'll do is just come and add a closed curly here. Then you're in big trouble. Now everything's confused. If your curlies are out of balance, figure out exactly where the curly needs to be. Don't put it in somewhere arbitrary because you might be making more trouble. Okay, so all methods have to be within the open and closed curly of the class itself. And we know it's the open and closed curly of the class itself because it's the open curly that follows the line class. Okay, and then we Control Shift P to see the corresponding closed curly, which many times, 90% of the time, is the very last curly. A method must be within the class but a method cannot be inside of another class. In other words, you can't put your phone inside of somebody else's phone. So if I take search clicked here, okay, if I move that inside of on create options menu, okay, if I do this, it won't work. Okay, we'll get red lines and it's very confusing. Avoid that. Make absolutely sure that you don't put a method within a method. Methods can be siblings, okay? Methods can be siblings, they can't be nested. So the only place where you can put a method is within the class itself, but not within another method. Okay, the order of methods really doesn't matter. So you can have one method above or below another, that's fine. You just cannot have one method within another method. You can't do that, that's illegal. You can't have a method that sits outside of a class. Sometimes I'll see a program where somebody starts making a method here, public void foo, like so. Method looks great, but the problem is it's outside of a class. So it's going to do no good and you're going to get a red line. Red line will say syntax error on token, open curly, delete this token. The problem is as soon as you do that, your curlies are out of balance. So be careful. Methods must be within the class itself. Now this is pretty easy to read. You see that the class is flush left, and you see all the methods are one tab stop in. What I see sometimes is sloppiness, and sloppiness will get you in trouble. Let's say that we kind of have it random like this. Let's say that we just have our curlies and everything going everywhere. If you do that, it's much harder to tell what open curly belongs with a closed curly. You'll get lost, you'll lose track very, very quickly. So you want to avoid this. Now, occasionally it does happen. You do some copy and pasting and your tabs get messed up, okay? But there's an easy fix in Eclipse. With your cursor in the source file, hold Control A, keep your finger on Control rather, and then press I. What that is that's an auto indent that will automatically indent the file according to whatever format has been set up. In this case, every time we have a curly, we tab in one. This looks much, much neater. When you submit your programs, I'll expect that you'll go to each file that you've written, Control A, Control I to automatically indent. That makes it much more easy to read. Okay, just a few more thoughts. Another thing I see a lot is when you call a method, and remember this is a call to a method, you must have one value for each parameter defined. Sometimes I'll see people mismatch that. They'll put in an extra parameter. That simply won't work. The data that you pass into a method, must match the parameter list for that method. Okay. It also has to be the same data type. If I surrounded this one with quotes, it would no longer be an int, it would now be a string. And string int is different from int. So the data types have to match up. If you're calling a method that's expecting 2 ints, you need to make sure you're passing in 2 ints. So those are probably the most common issues. Let's go ahead and run this and watch what happens when we're expecting that the sum of 1 and 2 is going to be 3. So what I'm going to do now, for the interest of time, I'm going to pause this recording as I bring up the emulator. We'll go ahead and start the emulator. We're going to say run as an Android application, and I already have one running, so hopefully it won't take too long, but I'll pause the recording just in case. Yep, there we go. And we'll let it come up. And we're not actually accepting any input. All we're doing is we're enabling the search button. We'll come back and we will accept input in a later video, but for now we'll just go ahead and leave it as it is. Now it's a little bit tricky to fit this all on one screen with the emulator, so I've had to move my screen capture software a little bit. But what you will see is, sure enough, if I hit search, the pop-up appears and it says the sum of 1 and 2 is 3. So those are some common programming practices and common errors that we see with them. So we know variable is a named place in memory. It must have a unique name and a type, and a variable has scope. The scope is the point where it is declared. All way to the closed curly where it is declared. This is what we call a local variable because it's local to a method. It's only known with inside of that method. This is what we call a parameter variable because these are parameters that are being passed in. There's also something called an attribute or a field. We haven't covered that yet, but we will in our next lecture. We know that this is a method. A method is like a phone. A phone has a phone number, a unique identifier. We know this is a call to that method. Both of those concepts are very important. Okay? We know that curlies are very important. We know we can go that every open curly must have one and exactly one matching an opposite closed curly. We know we can navigate from one to the other with Control-Shift-P. We know that it's important to keep our tabs at a standard level. So every time we have an open curly, we indent by one. And we know that if for some reason our indentations get out of whack, it's a good idea in Eclipse to do a Control-A to select all, and then a Control-I to auto-indent. So that is enough to cover us for this video. In our next video, we will take a look at how we can use those fields or attributes to get widgets or views from our layout into our activity. And as soon as we get them into the activity, we can program against them. So instead of saying sum of 1 and 2 and hard coding the 1 and 2, we can actually prompt the user for these values 1 and 2. So that's all I have for this video. Looking forward to catching you on the next. Thank you.